Hi viewers and learners, welcome to Ikemat with Theorem. And today our focus will be on chemistry and the topic is mole. Okay, then before we dive in, we have success is a process, not a quick fix. Success is a process, not a quick fix. So I want to implore you as a student, don't try to go through the route of quick fix. For example, you are preparing for test or you are preparing for exam. Maybe that's when you start reading the compiled notes. It's not advisable. So every day, make it a process of learning. As the school resumes, make sure that you try another method this time around. Start reading as soon as you are taught whatever concept you are taught in every subject. Make sure you read every day. So as you do that every day, that is a process that is leading you to success. Right? So having said that, let's look into what we have to be. Moles. What is a mole? What is a mole? A mole is the amount of substance, okay? The amount of substance that contains as many elementary entities as present in 12 grams of carbon 12, meaning that you can have carbon 13, carbon 14, but the standard that is used is carbon 12. So the amount of elementary entities that is present in a substance, just the same way it is present in 12 grams of carbon 12, that is what is called a mole. So the entities can be particles such as atoms, molecules, ions, and the subparticles. So now there are different formula that is useful when you want to solve any questions, any calculation of moles, right? So one of them is number of moles is equal to reacting mass over molar mass. Reacting mass will be in gram, while molar mass will be in gram per mole. And eventually, if you divide it, you will get your value in terms of mole. You can also have number of moles is equal to number of particles divided by Avogadro number, which is 6.02 times 10 to the power 23 particles per mole. Alright, I didn't remember to mention this, that the number of atoms in a mole is what is given by Avogadro's number. Okay. So now, if you look at, then there's another one I think I can still add it. It's concentration multiplied by volume. The concentration will be in mole by dm cube, while the volume will be in dm cube. Most times the volume will be given to you in centimeter cube. So therefore you will have to now divide it by 1000. Alright. So it will now turn out to be concentration multiplied by volume divided by 1000 as a result of the conversion. Right. So let's look at this. How many molecules are there in 40 grams of nitrogen gas at standard temperature and pressure? Now, the first thing to do is number of moles. To look at this, we're given reacting mass. So number of moles equals reacting mass, because that's the mass that, according to this question, that's the mass that is used to react, divided by molar mass. Alright, so you have your reacting mass is 14 grams, while the molar mass, remember the question says nitrogen gas. So because it is nitrogen gas, it is diatomic, meaning that it has two atoms, right? So you are given that the mass number of nitrogen here is 14, and because it is diatomic is having atom of 2 since it's a gas, right? So you have 14 multiplied by 2. So this gives you 14 divided by 28, and of course you know this will give you 0.5 mole. So that is the short form, 0.5 mole. So that's 0.5. So this is like 14 grams divided by gram per mole, which is 0.5 mole. So now you are cutting mole, you are not cutting molecules. There is a difference between calculating mole and calculating molecules. Remember, molecules is the smallest particle of a substance that can exist alone and still retain the chemical properties of the substance. I've mentioned that in the previous video that we did. So now, there is tendency for a student to think he has calculated molecules when he has calculated moles, and that's why this is very important to pay attention to. Now, since you are going to calculate number of molecules, you apply another formula of moles. This says particles divided by. So particles which can be molecules, ions, and subparticles. Okay, so we have number of molecules divided by the Avogadro's number, which is 6.02 times 10 to the power 23. Okay, molecules per mole. I have to write it like this so that we can realize that what we are doing is alright. So number of molecules is equal to 6.023 times 10 to the power 23 molecules per mole. So the reason personally I always want to put it like this is because you can easily know how your unit is involved. If I say molecule, you can see it. I say molecule divided by molecule per mole. Molecule divided by molecule per mole. You know that this will be molecule multiplied by mole divided by molecule. Okay? So this will cancel this, so you have one. Right? So it's the same way. Now you have calculated the number of moles already, so you just say 0.5 moles equals number of molecules divided by 6.02 times 10 to the power 23. So you are going to cross multiply. So when you cross multiply, your number of molecules gives you 0.5 half of. I'm multiplying 0.5 times multiplied by 6.02, and the 0.5 is half. So half of this will give you 3.01 times 10 to the power 23 molecules. Alright, so I have that. That's my answer. That's the answer. Alright, so why don't you go ahead and solve this one? To solve this question, let me give you an hint to that. What is the mass of this? So remember, I have introduced to you a formula here that you have reacting mass over molar mass. So, and you are told to calculate the mass of these atoms. So that's to tell you that instead of molecules, you are now dealing with atoms. So you are still going to apply into formula to solve this. So why don't you go ahead and solve it, and let me see your solution in the comment section. So till we meet next time, let me remind you again: success is a process, not a quick fix. Don't go to the root of quick fix. Go to the root of process, and you will achieve your success easily. Alright, so till we meet next time. Bye.